Okay, so let's talk for a minute about the column space of a given matrix A. But before we get there, let's take a look at the matrix U over here, which is an upper triangular matrix resulting from performing row operations on matrix A. The two matrices A and U are certainly not equal. That's why I don't have an equal sign here. But they are said to be row equivalent. Now, when we look at our matrix U, it consists of a row of zeros and two non-zero rows. In other words, row number 1 and row number 2 are the two non-zero rows of matrix U. Now, the first digit in each non-zero row, in other words, the digit 1 here and the digit 7 here, are called leading variables or pivots. So these two numbers, the number 1 here and the number 7 here, are called the pivots of matrix U or leading variables. So let's just write it down here. So 1 and 7 are the pivots. And of course, following onto that, the columns which contain the pivots, in other words, column number 1 and column number 2, are called pivot columns. Now, the question, of course, is what does matrix U reveal to us about matrix A? Well, first of all, this means that column 1 and column 2 in matrix A are linearly independent. So let's write it down. So column, hey, is that how you spell column? Column 1 and column 2 in matrix A are linearly independent. Now, it also means that these two columns, they form a basis of the column space of A. In other words, any vector in the column space of A can be expressed as a linear combination of these two vectors. So, for example, if we have a vector X in the column space of A, then X can be expressed as alpha multiplied by 1, 4, 2. Let me get a better pen. 1, 4, 2, the vector 1, 4, 2, plus beta multiplied by the vector 3, 5, 6. In other words, any vector in the column space of A is a linear combination of these two vectors. And remember, they are linearly independent. So what is column space? The column space is a set of all the vectors which are in this linear combination of these two vectors. Now, we also say that the column space is spanned by these two vectors. Okay? Now, what else can we say? We can also say that given that we have two pivot columns in U, this also means that the rank of the matrix A is 2. So rank of A is equal to 2.